Welcome everyone to this UR 2020 community session on nature-based solutions, balancing risk and societal benefits. This session is convened by the Horizon 2020 project Physicus on behalf of four Horizon 2020 projects that deal with nature-based solutions for mitigation of risk of hydrometeorological hazards. And the four projects are Physicus, Reconnect, Operandum, and NIAD. My name is Farrokh Nadim. I'm a technical director at the Norwegian Geotechnical Institute, which is the organization responsible for coordination of Physicus. And I'll be moderating this session. Before we start, I should inform you that this session is being recorded. So if you have any objections to that, or if you don't like that, you can leave the session. Our first speaker is Mr. Ken Ho. He's the Deputy Head of Geotechnical Engineering Office of Hong Kong Government. And his lecture is about natural terrain landslide risk management. Just to mention that we have 5 speakers this morning. Sure. And the first 4 are live. The last one is pre-recorded. Please, Ken, the floor is yours.
Thank you, Farrokh. I'm going to share with you our experience with the application of nature-based solutions to the management of landslide risk in Hong Kong. Waiting for you to go to the next slide. Okay, good. Hong Kong has a steep, hilly terrain, which is prone to rain-induced landslides from substandard man-made slopes and debris flows from natural hillsides. Landslides have brought about many fatalities and major economic losses in the past. The situation could become worse due to the impact of climate change. To reduce the risk posed by vulnerable natural hillsides to the community, structural countermeasures, such as rigid or flexible debris-resisting barriers, as shown here, are often provided as mitigation measures to protect important or critical facilities from landslide impact. Soil bioengineering, as defined in the first bullet point here, is one form of nature-based solution. Soil bioengineering measures may be used to repair landslide scars, reduce soil erosion, and prevent shallow slope movement, as well as to enhance biodiversity and resilience to extreme weather events. Where appropriate, soil bioengineering may be used in conjunction with sizable structural countermeasures as a blended green-gray approach to manage landslide risk. Let me now take you through 2 demonstration sites in Hong Kong, showcasing the application of soil bioengineering to repair landslide scars on natural hillsides. The first site is at Cloudy Hill. This is a summary of the range of soil bioengineering measures provided, which involved mainly the use of native rooted woody species, together with native live-cut branches that were harvested from around the landslide scars. A modular design approach was prescribed by the designer based on detailed site mapping and experience. Here are some pictures of the site works in progress during the installation of the various measures. Comprehensive performance monitoring is essential for quality data and improved understanding of actual performance. For example, we observed that in general, rooted plant outperformed live-cut materials in terms of short-term survival rates. In evaluating the overall effectiveness of the various measures, we considered systematically a range of factors such as control of erosion, establishment of a diverse plant cover with a self-sustaining plant community, improvement of the nutrient content of the soil, etc. All in all, the use of soil bioengineering was found to be successful in rehabilitating bare landslide scars based on the overall assessment. Pictures taken at different times. The second site is in Upper Keung San, where soil bioengineering measures were used to replace the shotcrete cover provided to the extensive natural terrain landslide scars during the emergency repair works. The design of the soil bioengineering works involved careful matching of suitable measures to the local site conditions, with collaborative input by the design team, comprising geotechnical engineers, ecological professionals, and arborists. And again, locally harvested native plant materials were used as far as possible, supplemented by suitable species from nurseries. The enhancement of biodiversity and ecology was achieved primarily through judicious selection of native species with suitable habitat characteristics, including the ones as shown at the bottom of this slide. To promote waste recycling, active reuse of shotcrete on site was implemented for the construction of pole drains. In total, some 250 cubic meters of shotcrete were reused. The overall outcome is pretty good so far, with the gray outlook being gradually turned back into a green outlook, together with enhancement in the ecology and biodiversity. We in the Geotechnical Engineering Office have promulgated best practice guidelines on the application of soil bioengineering to landside scars, as well as the provision of a sustainable vegetation cover to man-made slopes. These guidelines are intended to promote the upscaling of the application of soil bioengineering and green landscaping treatment as a nature-based solution in practice. And the policy of the Hong Kong government is to make the slope cover as green and as natural as possible. Nature can also be our teacher, and it can inspire us to develop some innovative measures for landslide risk management. For example, current research in Hong Kong is examining the potential use of the bioshield concept, as shown here, which comprises a network of engineered mature vegetation acting effectively as a green, flexible buffers to dissipate the energy of debris flows. Currently, we are doing flume tests as well as centrifuge tests on these with joint input from geotechnical specialists as well as ecological experts. Another example of learning from nature is the bio-inspired or nature-inspired soft-jointed baffles, which seek to improve the efficiency of baffle performance in the attenuation of debris flow impact. Based essentially on inspiration taken from tree root anchorage action. Here the slide depicts the basic concept of the new design of these so-called soft-jointed baffles, which seeks to spread the load transfer, the impact load, the dynamic impact load, in a more efficient way, largely onto the foundation and into the soil. Okay, so thank you very much.
Yeah, thank you very much, Ken. I suggest that we make the first 4 presentations and then we start some question and answers and discussions. The last presentation is pre-recorded, so we can go to that last presentation after the discussions. So our next speaker is Dr. Anna Skobolik from University of Geneva, and she will talk about governance and policy innovations through nature-based solutions. Please, Anna, the floor is yours.
Good morning, everyone, and thank you, Farag, for the introduction. Can you see my screen?
No.
No.
Now we see it.
Okay. Thank you.
But it's not in the presentation mode. Can you?
Okay. I will try it again.
And Ken, you can also turn off your camera if you like.
Does it work now?
No, we don't.
It's strange because it's...
Are you running on 2 displays? Have you got another monitor, or are you just running on 1 laptop screen?
On...
if you have 2 monitors, you should switch.
I just wonder if the presentation mode might be going to another screen.
Okay, I will...
You can see it quite clearly like that.
Yeah, I think maybe just go with that.
Just go with that. It's okay.
Yeah.
Don't worry about it. We're losing time, Anna.
Yes, I'm sorry about that. I just don't see my presentation anymore now. It's strange because we tried it.
Can you maybe just show it, but not in presentation mode? So just have the slides up in the kind of edit mode. That might work as well, because then at least you can see them.
Like that, you can see them.
Yes.
No, we can't.
No, we don't see any.
No.
Are you sharing the screen?
Yes, I do. And it usually always works. I do it quite often.
It's hard without seeing it, because now we can see
No,
it.
now we can see it. Can you see it yourself?
Yes.
Okay, just go ahead.
Okay.
Okay. Sorry for this inconvenience. I will try to, to go quicker. So the realization of nature-based solution, like the ones beautifully presented by Ken, depends critically on the policies and governance frameworks set in place. Yet, do we really have effective instruments and frameworks? And how can we catalyze innovation? In my presentation, I will focus on these issues, and I will present some results of research conducted on enablers that proved essential for NBS's initiation, planning, design, and implementation, with a focus on disaster risk reduction measures in Italy, Germany, and China, and on policy reforms that are necessary to drive net NBS transformation with a focus on European policies. But let's begin with an overview of the international policy context. So the Sendai Framework is one of the multiple international policy frameworks that are calling for a transformation. Yet, as we know, still nearly 90% of disaster funding is for post-disaster response, and only 10% is for disaster risk reduction. Also in the Paris Agreement, there is a call for transformation to reduce emissions. And NBSs are also mentioned there to help achieve these goals. The Global Commission on Adaptation calls also for transformation to close another emerging and relevant issue, the climate adaptation gap. And also the biodiversity agenda is strongly focusing on nature-based solution. But can really nature-based solution contribute to the nexus of this transformation? And how can we enable the co-benefits that are emerging from the integration of these different agendas? I will begin with examples from the governance sector. And nowadays, governance is a very popular term in social science, and it's used freely and sometimes also incoherently. But by governance, we refer to all the set of actions, processes, institutions, that are exercised in order for decisions to be taken and implemented effectively. And it's about the policy processes that make NBS happen. So there are a number of principles for effective and good governance. And you can see in the figures some of them: transparency, responsiveness. But how can we really catalyze innovation in governance? Here I will present the results from 3 case studies of successfully implemented nature-based solution, respectively in southern Italy, a case of landslides risk mitigation measures. We have a case from China on forest conservation for reducing landslides and flood risk. And we have a case from Germany, the Isar River, and the ambitious flood protection scheme that has been implemented there with a strong focus on nature-based solution. So in our work, we focus on 2 research questions. How do the public authorities and stakeholders view the success of the implemented NBSs in terms of their benefits and co-benefits? As you can see from the figure, we developed a life cycle of governance, and we addressed what were the stakeholders' view on the enablers as preconditions, so before the NBS was even conceived, for the initiation, planning and design, for its implementation, and then for the benefit and co-benefit realization, because as we have already mentioned at the very beginning, NBSs has this power of bringing together multiple agendas, not only on the international level, but also at the local level. So it's about not only, for example, disaster risk reduction, but aesthetic value, environmental benefits, cultural, social, and many others. The second research question was focused on the pre-existing condition and the enablers. So we categorize benefits and enablers on the basis of a number of different aspects. As I mentioned before, societal, technical, environmental, but also a number of institutional and political and intellectual economic aspects come together when NBSs are put in place. So here I will focus only on some of our main results and on governance innovation demonstration in relation to 3 key areas. The first one is about polycentric governance. So one key catalyst of this project was the fact that there were novel arrangements in place in the public administration that involved the multiple institutional scales and sectors to work together. For example, waste management, disaster risk reduction, technical and cultural offices were working together in different ways. Another key element was the co-design and the involvement of different stakeholders that had some key benefits in terms of conflict, local conflict reduction, but also overcoming of decision stalemates. Finally, also financial incentives, like, for example, payment for ecosystem services that have been implemented in the Chinese case, were really making the difference. There were a number of other key enablers, and here I will mention only the critical role played by local champions and advocacy coalition and groups that were really driving the implementation of NBSs. So another key aspect that is strongly related to the governance at the local level is also the policy. So we need the robust policy, legal policy instruments, legal framework that allow all this nature-based solution to be implemented. And our analysis here is focusing on the landscape in Europe. European Commission is investing considerably in NBSs with the goal of positioning Europe as a leader for innovation with nature. But very little guidance is provided on many different aspects. For example, how to monitor progress in the NBS adoption, how to integrate the concept into other type of planning, and how to integrate planning of NBSs more in general with other urban and other sort of plannings. Another issue that you can focus on is related to the figure and the fact that NBSs are very rarely included in mandatory requirements or standards. In the figure, it's the blue color identifies when NBSs have been included as mandatory elements. And as you can see, this is related to very few policy sectors. So in our project, we have been working with a number of experts in the academic, but especially in the private and public sector, to better understand these aspects related to governance and policy innovation. We set up a policy business forum, and we address some questions related to how can we mainstream NBSs into policies, and what policy reforms are necessary to drive transformative actions. So some of our key results, are summarized in these slides, where we focused on existing barriers and options. For example, some of the barriers emerged from the discussion with experts included the fact that NBS often require expensive land acquisition and making upscaling very difficult. We are missing not only technical guidelines, but also liability guidelines for practitioners to be able to better implement NBSs. The benefits of NBSs are, for example, less visible in comparison to those of gray infrastructure, and this makes them less politically attractive sometimes. And also their use of different NBSs definition can generate inconsistencies or confusion in the acquisition of possible fundings. But here in the next slide, before concluding, I will focus on one key element, that is the fact that many European policy mechanisms enabling NBSs remain voluntary with no legal obligation to comply. And some of our experts mentioned some ways to foster NBS enforcement. For example, focusing on the common agricultural policy in Europe, conditionality has worked in the past, and some measures like buffer strip at the small scale can increase effectiveness at the larger scale, and this can benefit not only agriculture but also flood risk reduction, for example. Another example is the enforcement of certain land proportion of forest cover for each member state. So these are some direction that we should pursue if we really want to foster a transition towards more effective NBS policies and governance. So now finalizing summarizing the ways, my presentation with three key inputs on ways forward. So as we have seen, the transition to NBSs can contribute to build synergies between multiple agendas, not only at the global level, but also at the local and regional scale. If we want to foster governance innovation, we have shown how some key elements are polycentric governance arrangement, promotion of co-design processes, and of novel financial incentives. And we also need to work more on how can we innovate and change the policy instruments that we have at our disposal, and with a specific focus on NBS uptake and upscaling. Thank you for your attention. And last but not least, I wanted to thank the project Fusicus, where this work has been conducted, and also my colleagues and the International Institute of Applied System Analysis that contributed to this presentation. And I'm happy to reply to your questions also in the chat because of the limited time.
Okay, thank you very much, Anna. I see that there's a couple of comments and questions to you in the chat box, so maybe you can respond to them. And our next speaker is Dr. Dayan Munasinghe. He's a senior scientist at National Building Research Organization of Sri Lanka. And he will present to us application of nature-based solutions for disaster risk reduction in Sri Lanka. Please, Dayan, the floor is yours.
Hope everyone can hear me. Hi, good afternoon and good morning, like depending on your location. My topic is application of nature-based solutions for disaster risk reduction in Sri Lanka. And I'm going to cover up the background of study, capacity building, analysis of plant species, site selection criteria, and NBS applications, and one case study during this presentation. Actually, this is ongoing project activities in our division. So the background, our NBRO is a focal point for landslide risk reduction in Sri Lanka. And we have declared 10 landslide prone districts in the country. NBRO initiated the landslide zonation mapping program for identifying landslide probable areas, and then mitigation activities are conducted to reduce of risk. However, in 2019, with the funding from the World Bank, NBRO implemented the nature-based landslide mitigation activities with the technical advocacy from Asian Disaster Preparedness Center. The aim of this project was to introduce the nature-based hybrid solutions for the landslide mitigation activities by promoting greener environment. The project has different tasks and implemented in 2 phases. So in the first phase, capacity building approaches, legal and institutional frameworks, pilot studies, and validation the results were conducted. And in the second phase, the assessment of the risk values, site-specific mitigation activities, and stakeholders knowledge sharing workshops were conducted. However, in this rest of the presentation, I'd like to emphasize few key activities that would be really important for the implementation of nature-based solutions for risk reduction activities. So capacity building applications. The different type of training programs were conducted for promoting of nature-based solutions for the landslide events. In addition, basic level and advanced level knowledge building programs were conducted to provide more technical know-how on the nature-based solutions. The computer-based applications such as KU software, Google Earth Engine were discussed to estimate and gathering of data for assessing purpose. Bioengineering methods, way of improving mechanical and hydrological properties of the soil through the vegetation, compute the plant root-based suction are the key subject areas in these training programs. Addition to that, group works and on-site training were conducted to understand the theoretical and practical backgrounds. Analysis of plant species. The identification of relevant plant species are the one of key element in this project, and for that we have identified a criterion to rank the plants. The criterion was based on few variables: plant type and structural characteristics, economic values, ecological significance, root strength characteristics, and hydrological significance. Each variable divided into several categories, and 1 to 5 marks were assigned for each ascending order. The highest mark received plants were the most suitable plants. Root strength is a variable of this criterion, and we tested root tensile strength at the laboratory. Here you can see some of the strength and values according to the mean diameter of the roots. Then plant manual was developed for selecting the suitable plants for the nature-based landslide mitigation works, and the way of selecting the plants were also developed. According to the process, the plant have been identified by considering the different site-specific data mentioned in the presentation. The site selection criteria was developed to apply the knowledge into the real practice, and for the first phase, 2 sites were selected, and 4 sites were selected for the second phase. These sites were selected by evaluating 15 sites around the country. The selection criteria was consisted of depth to failure plane, slope category, suitability of creation of vegetation cover, sustainability and maintainability, and finally potential damage or probable loss. The AHP technique was used to assign the weights for each factor. The diagram shows the site selection process in detail, and map shows the selected site locations. The different nature-based solutions were generated for each selected site, and few sketches are shown in the below. Considering the risk status, hybrid solutions were applied to the site, and some of them are coupled with the architectural perspectives. Here we are expected to brief about first site, which is located near the Uwawellassa University of Sri Lanka. The village name is Badulu Sirigama. This site is located in Badulla, which is the administrative city of Alla, a famous tourist destination in Sri Lanka. The land movements were detected in 30 years ago, and afterwards few movements were recorded. Considering the vulnerability of the area, 95 houses units, around 355 people and infrastructure facilities were vulnerable elements due to this landslide. Even consider about the social status, majority is male-headed family, and most of them are government sector employees. Most of the buildings are residential and constructed with load-bearing walls, and most of houses has systematic drainage systems to control the wastewater. 69% of buildings are located on the general slope, and 42 houses unit have landslide symptoms. The weakest point was 75% respondent says that they didn't receive any preparedness instructions. The landslide map program was also identified that area has a significant hazard activities. Scenarios. The slope had been divided into 3 sections, and named as Zone 1, Zone 2, and Zone 3. Then the scenarios had been developed for the further assessment. The scenarios are slope without any mitigation measures, modified slope with subsurface drainage, and modified slope with application of hybrid systems. Factor of safety values had been simulated by using the GeoStudio for each scenario, and table shows the factor safety values. Limitations are also described in the slide. According to the calculation, the mixed method combination of vegetation and drainage, scenario number 3, was improved the safety factor on the slope. Therefore, it is suggested to use appropriate vegetation with drainage improvement for the mitigation of the risk. Then the conceptual map was developed, and activities were identified by considering the several stakeholder discussions. Accordingly, a drainage improvement was conducted on the slope area, and total areas divided into 3 zones, where community engagement zone, university engagement zone, and the nature park with some nature trails. Now this plan is implemented on the Thank you.
Yes. Yeah, thank you very much, Diane. Our next speaker is Professor Zoran Vojinovic from IHE Delft in the Netherlands. He is also the coordinator of one of the 4 projects which is convening this session, the Reconnect project. And Zoran will make a presentation about multifunctional potential of nature-based solutions. Please, Zoran, the floor is yours.
Thanks very much, Farrokh. Can you please confirm that you're hearing my voice and you are seeing my slides?
Yes, we hear your voice and we see your slides. It's not in the presentation mode, but we see. Okay, now it's perfect.
Yes.
Now it's perfect. Yes.
Okay, thanks very much once again for this invitation. I will be presenting a few slides, and as you mentioned, I will also bring the experience from the Reconnect project, which is the assista project to Fusicos and Operandum. I will briefly just run through some of the aspects that I'm going to be talking, just touch upon the background of the nature-based solutions and why and how. Then I'll briefly talk about the benefits and co-benefits. I will be talking about the perspective of the Reconnect project and some of the work that we've done in relation to the comparing some trade-offs, and I will show some examples. Basically, as an introduction to this, I don't think I don't need to spend much time by saying that there's so much evidence that we are facing quite some climate extremes nowadays that used to be, once upon a time, we used to be from one year to another, but now we have many examples around the globe that people within one season experience either 2 wet periods and then 2 dry periods. As a consequence of that, we have seen some major events occurring around the world. This is the 2017 Hurricane Irma that hit and struck the island of St. Martin, which is coincidentally one of our case studies in the Reconnect project, and made enormous destruction to that island and also to some other neighboring islands in the Caribbean region. In 2013, before Hurricane Irma struck St. Martin, there was a Typhoon Haiyan that hit the Philippines. Up until 2013, it was estimated to be the most severe typhoon, which is in the Caribbean region referred to as hurricane event. But then Irma got the new #1 spot on the chart of these extreme events. In terms of the other kinds of floods, we've seen in 2011, Thailand floods have taken really a massive toll on Thailand for a period of 2 months. Again, this is one of the cases that we have in the Reconnect project, and some damages and repercussions were severe following in the aftermath of this event. We also, on the other hand, we've also cannot forget that we've had quite some very impactful heat waves that took place in 2003 and also in 2015. And the number of deaths due to heat waves were in the order of 70,000, and some massive economic damages were imposed onto the critical infrastructure and other infrastructure. So we are facing situations we have too much water, and then also we have too little water. So now the traditional response to these events has been very much with the so-called gray infrastructure measures, which we can divide into small scale and large scale. And this is an example of a small scale radar measures which are typical for urban areas, with the pipes being the classic example of such measures. But then we also have as maybe large scale measures. Traditional can be a dike, which has been used. Of course, if it is done with traditional means, without these ecological or innovative approaches, it can be seen as a gray infrastructure that has been used along the rivers and also along the coastal areas. So we have interventions. So the nature-based solutions have emerged as obviously as a response that we want to really not only take the water from one place to another in a fast way, as it was the case with traditional measures, as soon as possible, but rather to retain this water for maybe some dry periods, to mitigate heat stress and microclimate in maybe urban areas, and for other agricultural and other benefits if it is in rural areas, in agricultural areas. So the focus or the mentality has changed from trying to take the water as fast as possible from one place to another, but rather to retain the water and process it. This is an example of some small-scale nature-based solutions, which are urban scale, like swales, green roofs, porous pavements, vertical and rain gardens, and things like that. We also distinguish between the small-scale and large-scale MBS. So now the large-scale MBS examples are, for example, afforestation or reforestation, retention or detention basins, ponds, wetlands, some bypass channels, and things like that. And in the Reconnect project, we are looking really at the large-scale nature-based solutions. There is a big difference in relation to hydro-meteorological risk reduction between the small-scale and large-scale MBS. Small-scale are really designed to handle these small events, which are rather nuisance and may not necessarily bring a wider disaster to the areas. In which case, the large-scale nature-based solutions play very important role because they are designed to retain large amounts of water, to deal with the large amounts of water, and therefore they have more potential to be used for the large-scale disasters, to prevent large-scale disasters. Very briefly, in terms of the evolution of terminology, we can find in the literature there are numerous different terms that have been used throughout the time, which more or less all refer to the same kind of measures, which is nature-based solutions. Nowadays, the term used by European Commission. So we have low impact developments in US 1977, best management practices, water sensitive urban design in Australia, sustainable urban drainage systems in UK, and so on and so on. We have all these terminology, which are nowadays nicely converging into what passes by as nature-based solutions. Another thing which is very important with nature-based solutions is the multifunctionality and ability to provide numerous benefits and co-benefits. If we compare them with the traditional measures like pipes, the pipe has one single function, which is to take the water from A to B, whereas with nature-based solutions, we can achieve multiple benefits and co-benefits because they're built on the ground and they can be used for such things. So this is an example that we use, that we are demonstrating large-scale MBS in Denmark. This is the case in Aarhus, brought together by the Aarhus municipality. What we see here is a large area which acts as retention storage to prevent the flooding of the urban area, and basically it functions quite well in that regard because the flood has not been much observed ever since this measure has been put forward. This is how it looks like when you get a large-scale flooding. So the water does not go to the urban area to the right, but rather stays in this within the lake. So that's one example of benefits. But of course, the core benefits would be enhancement of biodiversity, and social benefits would be in this area would be recreational and other activities that this particular area offers. So besides, as I mentioned, the primary objective, which is the hydrometeorological risk reduction, the core benefits in this context are related to biodiversity and also social and human well-being. Very quickly, about the project. The Reconnect project combines 36 partners with about 14 million euros from the contribution from European Commission, and the overall value of works is in the order of 40 million euros. We have 10 demonstrators where we are demonstrating large-scale nature-based solutions, and we have a number of what we like to call collaborators in Europe and abroad, where the idea is that we are replicating and upscaling these measures and developing the so-called NBS master plans for these locations. So in our work, we are looking not only in MBS, but we are really looking in a combination of interventions, small scale, large scale MBS. Of course, the focus is on large scale, but we are really looking how the large scale MBS can function in relation to small scale and also in relation to gray infrastructure. This is very briefly our theory of change in the project, that we are going from training, co-creation, dissemination, replication, exploitation results, partnering, and advocacy. Here, really, we are at the point where we are dealing with the replication of MBS. And for example, we are taking a number of examples in Europe. This is from the Netherlands, the project or the program called Room for the River. where this is an example from the Nijmegen, where you see the area which used to flood quite regularly, but now with the provision of the bypass channel and adjustments of the floodplains, basically there has not been not even a single flood incident, but there are so many nature and also social benefits that have been observed. So in this project, we are taking the measures that we can replicate, and as in the previous presentation, Anna talked about enablers and barriers. We are looking where these enablers and barriers can play a role, and how much these measures can be replicated in our collaborators and also other parts of Europe. Very last, I want to finish off in a couple of minutes. I show you also the range of measures we are looking at. We are also looking, I've started presentation showing the massive hurricane impact on the island of Saint Martin. We are also looking, we are not only looking at the river-related and nature-based solutions, but we are also looking in the coastal areas. And we are using this example from Saint Martin, which was really, really severely hit by the hurricane. Back then, we have done all kinds of hazard, vulnerability, and risk assessment. And we identified areas which are more prone to flooding. And then we looked into some trade-offs between different measures with and without benefits or co-benefits. And we looked in combination of the inland measures and also the coastal measures. And for the coastal side of story, we are looking at the artificial reefs, living breakwaters, seagrass bed restoration to dampen some of the potential coastal waves that affect the area, and also mangroves restoration. So to conclude, in the Reconnect project, we are looking really at taking the potential of MBS in the sense of addressing the producing the evidence base, and looking at the replication and upscaling of these measures throughout Europe, but also outside, by combining the measures, comparing their trade-offs, working alongside with stakeholders to design multifunctionality, robustness, adaptivity, and flexibility of such measures. So this is, in a nutshell, the Reconnect project and the work we are doing in relation to MBS. So thank you very much, and I hope I didn't exceed too much time, Farooq.
No, thank you, Zoran. You were exactly on time. Now, the last speaker of our session here could not attend, so he has sent a pre-recorded message. But I think before we start on the last presentation, I take a couple of the questions that have come in the chat, but I think would be interesting to discuss them with Ken or with everybody. One of them was a question to Anna, that when she was discussing the enablers, if education was missing from her list, what she thinks about education at university level about this MBS as an enabler of MBS in the future. So could you, Anna, share your thoughts on this?
Yes, thank you for this question. I mean, certainly education is a key enabler. However, it was not emerging from the interviews that we conducted in our case studies as one of the main enablers for the project implementation. And I can imagine that this was due to multiple reasons. One is the fact that actually we don't have so much NBS education, NBS focused education at the moment. So we need to invest that. This can be a future enabler, and but is not yet there. And on the other side, our focus was strongly on the projects, so actually the physical measures and what was driving and catalyzing this. And education, again, was not mentioned. I mean, the thing is that in our work, we work with stakeholder views, so with which are also, you know, somehow individual ones. But yeah, sorry, I stopped there. We have limited time.
Okay. Thank you very much, Anna.
Thanks, Anna, for that one.
Yeah. And there was also a question to Diane, which must be interesting for many of you in the audience, is that you presented very interesting projects that are going on in Sri Lanka, but the question was, have you done any cost-benefit analysis for these projects? Are these solutions economically viable?
Yes, actually, we did some studies, and based on that studies, we identified several. I mean, we do several community workshops as well as some stakeholder workshops. In that one, we identified what are the community requirements in that one, And also we estimated what is the cost for the predominantly some structural mitigation, as well as when we combine these NBA solutions. So that's so we got some feedback, because the IR is more higher in this NBR in NBS. So that's why we go for this kind of solutions. Actually, we calculated some of the values for this project.
Yeah, thank you very much. And just a follow-up question: was this evaluation of ecosystem services part of your analysis, and then when you were considering the benefits?
Yes.
Yeah. Okay, thank you. So we don't have much time left, and we have one more presentation which is pre-recorded. I just wanted to make a comment about this session, that the idea was to present some of the activities that are going on in Asia and in Europe. And it seems to me that when it comes to hydrometeorological hazards, in terms of landslide risk mitigation, there's more activity in Asia, and maybe they have much more practical experience than in Europe. But when it comes to river flood mitigation and coastal hazards, then maybe that's where Europe is in forefront right now. But in all these activities, there's a lot to be learned, and there's a lot going on research, which makes it very promising for the near future. So our last speaker of this session, who unfortunately could not attend in person, is Professor Henglin Jiao from Hubei University of Technology in Wuhan, China. And he will discuss the research progress of slope ecological protection. I will try to share my screen and start his presentation. Hopefully it works well. If I can find it here. Okay, here we go.
Hello, everyone. I'm Xiao Henlin from the School of Civil Engineering, Architecture and the Environment, Hubei University of Technology. I'm very honored to introduce the progress of our team on the slope ecological protection. I will introduce our work in 3 parts. There are the research background, main research content, and the future research prospects. Firstly, I talk about the background of slope ecological protection. A large number of infrastructures where company, social development, mining and construction of highways, railways, and hydropower stations, we are produce a large number of artificial slopes, which brings about problems such as soil degradation, landslides, and ecosystem damage. Among them, the clouds is most intuitive problem. To make these slopes more stable, people may try to use some materials to cover the slope surface, such as the gluted block stones, the muddied rubble, the shotcrete, etc. Because of worsening the slope protection capability of this traditional method gradually declines over time. And as people become more aware of the ecological environment, the terrible landscape effect of the traditional slope protection method cannot meet the requirement of people. Either a new slope protection technology that can overcome the shortcomings of the traditional approach. The answer is yes. The new slope protection technology is the ecological slope protection method. At present, there is no accurate definition of ecological slope protection worldwide. Its purpose is to use live plants alone or combine them with non-living vegetable materials to reduce slope instability and soil degradation. The ecological slope protection method is the main work of our team. And this is the second part of our presentation. In this part, I will introduce the work of our group from three aspects involving ecological protection theory, mechanics, and technology. For the ecological protection theory, we promote the original ecological protection theory, which is to use excellent plants near the slope to restore the vegetation system of the slope as much as possible, similar as the original ecosystem. For the natural environment in Hubei province, we selected 9 kinds of excellent slope protection shrubs, 4 types of excellent slope protection herbs, and 3 types of perfect slope protection vines, based on 7 ecological function factors, including cold tolerance and barren tolerance. After that, we used the selected plants to conduct ecological slope protection model tests, and then performed the above-ground biomass analysis and coverage analysis of the plant on the test results. Finally, we used the comprehensive evaluation index method based on the analytic process to evaluate ecological stability. We conclude that the optimal grass shrub ratio is 1:5, and the optimum sowing rate is 20 grams per square meter. We have obtained the mechanical properties of herb roots and irrigated roots through experiments. According to 4 growth periods and 3 grass shrub ratios, we made 12 types of root soil complex. After comparing the shear test results of these complexes and rootless and disturbed soil, we concluded that the shear stress of the root soil complex is higher than that of the unrooted and disturbed soil. With the middle growth period, the advantage of the reinforcement effect of the grass soil mixture is insignificant due to intense specific competition. But with the short or long growth period, when the specific competition is stable, the reinforcement effect of the grass-shrub mix is better than that of single herb or shrub root reinforcement. The existence of root increases the cohesion of soil, and the cohesion research the maximum in 90 days, which is about 3 times that of the disturbed soil without root. Based on the results of finite element numerical simulation, the stability of the slope with vegetation is higher than that without vegetation. And this stability improvement effect becomes more evident as the slope becomes large. We have developed a new slope protection strategy based on hollow green brick and anti-slide pipe, a new ecological slope protection technology of frame beam, a new type of vegetation, complete green attitude, and a new kind of erosion control cover. For the first time, our team used the waste incineration ash as a substrate for ecological protection and developed a reasonable composition of this new material. Through shear stress and ecological tests of base strip material with different ash content. We have studied the mechanical and the environmental properties of the base material. Based on our research, the incorporation of fly ash improves the shear strength of the soil. When the ash content is 5% to 6.7%, the strength is much improved. The incorporation of fly ash affects the ecological performance of the substrate. Tests have shown that 20% of the ash content is an acceptable upper limit. That is, the ash content is not higher than 20%. Considering the mechanical and ecological indicators, about 10% of ash content is appropriate. Our research is supported by multiple scientific research programs from the government, and the new technology of development have been widely used in China. We have obtained 15 invention patents and established 3 industry or local standards. And our team had won 6 scientific research awards in China. This part is my final content of the presentation. I want to talk about prospects. Next step, our team will study the relationship between plants and slopes, such as the influence of plants on the infiltration of rainwater on the slope, and the interaction between the root system and the soil. Oh, thanks for your attention.
Well, thank you everybody for attending this session. We've already gone 5 minutes over time, but I hope you enjoyed this session, and it's also been recorded. So if some of your colleagues or students would like to look at this later on, it would be available through the event website. Goodbye, everybody.
Goodbye, thank you.
Thank you, goodbye.
Thank you.
Take care.